Okay, we're recording. So what we're going to look at here is an induction problem from the 2018 exam. Okay, we're going to be looking at all the steps of induction to prove divisibility. So we have 10 to the n take 6 to the n, and we want to show that it's divisible by 4 for any value of n. And then we have a second part to the question. So once we've actually proven that a pattern is true or that some proposition is true, then usually the next logical step of that question is to then use that proposition to find out some meaning of the pattern or the sequence or the series. Okay, so the bulk of this demonstration is going to be on the method of induction, and then we'll look at how we can use the pattern that we've proved to then find an answer to the second part. Okay, so the first thing that we're doing is we want to first define our proposition P of n. Okay, so first of all, what is our proposition P of n? So I'm going to check that we're recording. Yeah, all good. So our P of n, start off by saying P of n, our proposition for any value of n. We say that 10 to the power of n minus 6 to the power of n is divisible by 4. Okay, and we also need to define the range of our n. So n is all positive integers, so we say that n is an element of the set of all positive integers. Okay, so that's the first thing we need to do. We've defined our proposition. Okay, the next thing we need to do is we need to show that this, well, check, is this true for one value of n? Okay, we're just going to choose n equals 1 because that's going to be the easiest number to work with here. So I'm going to look at our proposition of when n equals 1 and check to see whether this is in fact true. So we'll have 10 to the power of 1 minus 6 to the power of 1. That's just going to be 4. Which we can see straight away, 4 is divisible by 4. Okay, so then we'll just formalize this and we'll say something like, therefore, P of 1 is true. Okay, so we've shown that this proposition is true for n equals 1. All right, now how can we show that it's going to be true for all n from 1 to positive infinity? Okay, so this is where we apply the process of induction. So what we're going to be looking at, first of all, we need to assume that it's true for some general value n equals k. And then using that assumption, we need to show that it will be true for the next value after k, which is k plus 1. So just to make a note here, we're going to assume pk is true, then use that assumption to prove P of k plus 1 is true. Okay. Now I know it's not the best writing with the stylus, so it's a work in progress. You're just going to have to bear with me on that one. Okay, so let's go ahead and look at our P of k. So our P of k is just when n equals k. So we just have 10 to the power of k minus 6 to the power of k is going to equal, well, it's going to be divisible by 4. So it's going to be an integer multiple of 4. So we can say that this is going to be equal to 4a. Now what is a? Well, we need to define that. A is just some integer. Okay, so if this equals some integer times by 4, then that's how we know it's divisible by 4. So we just need to define a as a positive integer. Or it doesn't even have to be a positive integer. A is just some integer. So it's the set of all integers z. Okay, a is some whole number. So if it equals 4 times a whole number, we know it's going to be divisible by 4. Okay, so this is our proposition for when n equals k. All right, so now let's look at our p of k plus 1. So p of k plus 1, okay, when n equals k plus 1, we have 10 to the k plus 1 minus 6 to the k plus 1. Okay, so what can we do here? Okay, this is our proposition of p of k plus 1. So what we want to do is we want to show, is p of k plus 1 divisible by 4 using what we know about p of k? So we're going to have to do some investigation, some algebraic manipulation and see what we can find here. Essentially, the goal is to substitute in our p of k. Okay, so we kind of want to get our p of k plus 1 to somehow look like p of k so that then we can substitute it in to our equation. Okay. So what we're going to do is, first of all, using what we know about exponents, we can say that that's equal to 10 times by 10 to the k minus 6 by 6 to the k. Okay. Now, one thing we can do here is we can break up this 10 here. We can break it into two factors of 6 and 4. Well, a sum of two factors, 6 and 4. So we'll go ahead and do that, and we'll see why that is actually going to help us in a minute. So if we make this equal to 6 plus 4 times by 10 to the k, take 6 to the k. Okay, and let's see what that gets us. Okay, so if we then go ahead and multiply out these brackets, what we're going to get is equal to 6 by 10 to the k plus 4 by 10 to the k minus 6 to the power of k. Now, what we'll see here is that we will missed out the first 6 here, so they'll 6 times 6 to the k. And this one here is also 6 by 6 to the k. So what we see is that we in fact have a common factor here between our 10 to the k and 6 to the k. We now have a common factor of 6, which we can take out. So this will help us with our algebra here. Now I'm just going to pause the video here because we do have a 10-minute limit, and then we'll continue on the next one to see how we can prove that p of k plus 1 is in fact divisible by 4.